Hello everyone, welcome back to another video of Analytical Angle, and today we are going to discuss questions on log identities. So today is going to be a very amazing session on logarithms, and we will do some really interesting and tough log questions. So the first question is already on your screen. The product of all positive real values of x satisfying the equation x to the power 16 log x base 5 whole cube minus 68 log x base 5 is equal to 5 to the power minus 16 is. Now this is a JEE Advanced 2022 question, so you can already think of the other questions that we are going to do in this video and what level they are going to clear. So let us begin. So first of all, let us take t is equal to log x base 5. T is equal to log x base 5. From this, we can write that x is equal to 5 to the power t. So now we write down the question again. So it is x to the power something. So we can write that as 5 to the power t whole to the power t cube minus 68t. So using the law of exponents, we can write it as 5 to the power t into 16t cube minus 68t, which is equal to 5 to the power minus 16, equals to 5 to the power minus 16. So taking log on both sides, we get t into 16t cube taking log on both sides minus 68t into log 5 is equal to minus 16 log 5. So from both sides we can cancel out log 5 as it is a constant. And now on factoring out t from the inner function, we get t square into 16t square minus 68 is equal to minus 16. And we notice that both sides are divisible by 4. So we divide them by 4. T square into 4t square minus 17 is equal to minus 4. So now if we put y is equal to t square, if we put y is equal to t square, we get y into 4y minus 17 plus 4 is equal to 0. That is equal to 4y square minus 17y plus 4 is equal to 0. And we can factor this out and write it as 4y square minus 16y minus y plus 4 is equal to 0. So this can be written as y minus 4 into 4y minus 1 is equal to 0. So this gives us y is equal to 4 or 1 by 4. So since y is equal to t square, we can write it as t square is equal to 4 or 1 by 4. And taking square root on both sides, we get t is equal to plus minus 2 or plus minus half. And since t is equal to log x base 5, we can write it as log x base 5 is equal to plus minus 2 or plus minus half. So x is equal to, there will be 4 solutions here. X is equal to 5 square or 5 to the power minus 2, 5 to the power half, or 5 to the power minus half. Now, since the question asks for the product of all the possible values of x, we multiply all of these and we get it as equal to 5 square into 5 to the power minus 2 into 5 to the power half into 5 to the power minus half. So this is equal to 5 square into 1 by 5 square into 5 to the power half into 1 by 5 to the power half. And so everything cancels out and we are left with 1. And that is our final answer. 1 is the correct answer for this question. So now moving on to the second question. So for the second question, it says, let A and B be real numbers greater than 1 for which there exists a positive real number C different from 1 such that 2 into log C base A plus log C base B is equal to 9 log C base AB. Find the largest possible value of log B base A. Now, this question, so let us begin. 2 into log C by log A plus log C by log B is equal to 9 log C by log AB. That is the question, right? Using the change of base rule. So we can break log AB as log A plus log B in the RHS, and it becomes 9 log C by log A plus log B. And for the left hand side, we can write it as 2 log C into log B plus log C into log A, entire thing upon log A into log B. So this becomes our simplified version of the left hand side and right hand side. Now on the left hand side, we can take log C common and write it as 2 log C into log B plus log A, entire thing by log A into log B. And this is equal to 9 log C by log A plus log B. So now we can write this as 2 log C into log B plus log A whole square is equal to 9 log A log B log C. We just cross multiplied between the RHS and LHS. Now if we take log C common from both sides, we get log C into log B plus log A whole square minus 9 log A log B is equal to 0. So on taking log C common, we can write this as log C into 2 log B plus A whole square, log B plus log A whole square minus 9 log A log B. This entire thing is equal to 0. So now the question has told us, if we go back to the question once, the question says that A and B are real and number C is a positive real. So if C is a positive real, then which is different from 1, that means C is not equal to 1. That means log C can never be equal to 0. Therefore, when we return to what we have found after all this hard work, we can eliminate the possibility that log C is equal to 0, and hence we can cut it off from our equation. So what remains is 2 into log B plus log A whole square minus 9 log A log B is equal to 0. On simplifying this further, we can get 2 into log a whole square minus 4 log a log b minus log a log b plus 2 log b whole square is equal to 0. And on factoring this, we get 2 log a minus log b into log a minus 2 log b into log a minus 2 log b is equal to 0. So from this we can conclude that log a is equal to half log b or log a is equal to 2 log b. So the question asked us to find the maximum value of log b base a. So that means log b base a is equal to 2 or 1 by 2. We apply the change of base rule, and thus the maximum value it can hold is 2. Therefore, our answer is 2. Therefore, the correct answer is 2. Now, moving on to the third question. Now, for the third question, the question is, let a denotes the value of log ab plus square root of ab whole square minus 4 into a plus b whole thing by 2 and plus log blah blah blah. Such a big expression will definitely frighten you, but it is actually a very easy question which we can solve like this. So capital A is equal to log AB plus square root of AB square minus 4 into A plus B, entire thing by 2, plus log AB minus square root of A minus 4 into A plus B, entire thing by 2. So we know that log A plus log B is equal to log AB. So we can write this as equal to log. Now before we proceed any further, we can see that the product will be in the form one thing squared minus another thing squared, because it is AB plus something on one side and AB minus something on the other side. So it will definitely be AB whole square minus the thing under the root whole square. So we can write that as log of AB whole square minus square root of AB whole square minus 4 into A plus B, this thing whole squared, this entire thing that is under the roots whole squared, and entire thing divided by 4, because 2 into 2 is 4. I hope you all know that. So this is equal to log of AB whole square minus AB whole square plus 4AB, 4A plus B, sorry. Entire thing by 4. Now AB whole square cancels out, and so this becomes log of A plus B. Now if we go back to the question, they have given us the values of A and B. A is equal to 43 and B is equal to 57. That means A plus B is equal to 100. So the value of capital A is equal to log of 100 base 10, which is equal to 2. Therefore, capital A is equal to 2. And they have asked for the value of A minus B, but B is something else. So B is the value of the expression 2 to the power log 18 base 6 into 3 to the power log 3 base 6. So B is equal to 2 to the power log 18 base 6 into 3 to the power log 3 base 6. Let us check once if we have written that correctly or not. Let us revisit the question once. Yes, it is correct. Now, if we solve for b, so b is equal to 2 to the power 1 plus log 3 base 6, 1 plus log 3 base 6, because we know that 18 is equal to 3 into 6 and log 6 base 6 is equal to 1. So I simplified that and wrote it as 1 plus log 3 base 6 multiplied by 3 to the power log 3 base 6. And this can be written as 2 into 2 to the power log 3 base 6 into 3 to the power log 3 base 6. Now, since the exponent is the same, we can club the bases together and write it as 2 into 6 to the power log 3 base 6. Now, 6 to the power log something base 6 will always be equal to something that is in the log. So, it becomes equal to 2 into 3. 2 into 3, which is equal to 6. And the question asks for the value of a minus b. Therefore, a minus b is equal to 2 minus 6 is equal to minus 4. And that is our final answer. Okay, so that's it for today. We hope you enjoyed this first part of our series on logarithms. Thank you. Subscribe, hit the like button, and comment down below.